My name is Kevin McNamara, and I'm a freshman in the College of General Studies. Next year, I plan to transfer into the College of Aces and pursue the ETNIS program. I chose to make my final presentation and write-up about photovoltaics and solar energy. Photovoltaics are defined as the conversion of light into electricity using semiconducting materials that exhibit the photovoltaic effect. Solar energy is the radiant light and heat emitted by the sun. My interest in this topic stems from an internship I had in the summer of 2019 at a solar panel startup tech company in Silicon Valley. At this internship, I learned a lot about photovoltaic cells and how they are used to generate electrical power. I had lots of hands-on experience with solar panels, and I learned how the professional world works in a research lab. The lab I was working in was aiming to improve the efficiency of solar panels in a variety of ways. I'm also passionate about clean energy and environmentalism, so this was a fantastic experience for me. Photovoltaics were discovered by a 19-year-old French physicist named Alexandre Edmond Becquerel. Becquerel devised an experiment where he placed silver chloride in an acidic solution and attached platinum electrodes to it. When this solution was exposed to sunlight, an electric current was generated and the first photovoltaic device was created. Photovoltaics have evolved over time and have seen many different improvements since their invention in 1839. Solar cells today are made up of two types of semiconductors, which are usually P-type and N-type silicon because of their conductivity properties. When the semiconductor absorbs sunlight, it knocks electrons loose on the N-type layer. These electrons eventually flow towards the P-type layer, which has holes that are waiting to be filled by electrons. An electrical field within the cell directs these loose electrons into an electric current. Solar panels are usually made up of hundreds of solar cells, each working together to generate power. Today, solar panels are used for a wide array of things and continue to grow even more popular. Solar panels are currently being used to power the International Space Station. The ISS has massive reflective wings on either side of the hull made up of thousands of solar cells. Thanks to the science of photovoltaics, astronauts can safely live in space for months at a time. Photovoltaic power stations have been built all over the world, and the largest stations are in the United States, India, and China. These stations are used to power hundreds of buildings. Some settlements in Europe are run strictly on energy from solar panels. Solar panels are also used to power public transportation. Railroads, subways, buses, planes, and cars have evolved to be solar-powered. Solar-powered buses are currently helping China reduce its massive carbon footprint. Solar cells are also being implemented into technology like lights, watches, phone chargers, fans, and so much more. The University of Illinois even has a solar car program that competes in races every other year. The Illini Solar Car team consists of over 150 members from many different majors, all working on two completely solar-powered vehicles. These vehicles then race in competitions all over the country and have most recently placed fourth in the 1,500-mile race from Independence, Missouri to Santa Fe, New Mexico. The team is currently looking to compete in the 2022 American Solar Challenge and is beginning designs on their third solar car. The Illini Solar Car team is something that interests me, and I may pursue it early next year. The future of solar energy is bright, and with the right application of photovoltaic technology, we can shift our focus away from harmful fossil fuels and take a step in the right direction in the fight against climate change. Currently, solar cells work at an efficiency between 18 and 22%. If such a low efficiency can already power massive settlements, one can only imagine what a more efficient solar cell will do for the planet. To put this in perspective, about 430 quintillion joules of the sun's energy hit the Earth every hour. The amount of energy that the entire planet uses every year is 410 quintillion joules. Effectively harnessing the sun's solar energy yields massive potential, and if a new way to harness this energy is discovered, fossil fuels will be a thing of the past. Access to affordable and reliable energy has already drastically improved the quality of life for millions of people. Still, many do not have access to affordable electricity. As clean and affordable energy becomes more readily available, more impoverished communities will become middle class. Solar energy and photovoltaics are the way of the future, and advancements in this field will lead to a new age of innovation.